Okay, now second part. Also one of my favorite question. I like to ask this kind of question. All right. Now second part is on the relative velocity between two objects or two particles. Now you can like put what you learn from the beginning until the rest just now. Now it's totally a different two things. The new things. So now we're going to learn what happens if you make a movement to someone, to the pulley, then something will happen. For example, the one you see over here, you're looking at pulley system. Now, you know that when you pull the rope, the red rope, the object will either move up or move down. And the pulley here will either move up or move down, right? And so on. So we're going to learn this kind of motion. We're going to study what is the relationship between the two modules. Okay, now this chapter or this section, what you need to understand is we're still looking at a few parameters. We still look at position, S, we still look at velocity, we look at A, and still look at time. So this question, when you look at this question, first of thing, you mark the first reference point. Okay, for example, the one you see on the screen here, you mark where is your reference point, in this case at the center O. And how you know this is a question related to absolute dependent motion analysis of two particles. In the question, you will see this datum word there, or maybe it will not tell you it is datum, but you will see two lines with one dot and arrow. Dot is your starting point. Arrow is your positive direction of from the datum. Meaning it already tell you where is positive S direction. It gives you a vector positive direction and it's fixed. Okay, so when you do calculation, you get negative means it's opposite direction. Okay, now first is your O, second is where is your datum. Datum tell you where is the positive, and so on. Okay, now this question is more on logic thinking. If you pull A, what happened to B? B move up, right? If you let go A, let's say A is more heavier, you will continue to move down. But if this one is heavy, of course A will move out. Okay, so this question, yeah, Lily, you need logic thinking. Right? Math will involve here. And okay, then we're going to, okay, first we use position coordinate SA and SB. So SA, SB, sometimes go to SC and SD and so on. Important is you know your datum. Don't confuse between the datum and datum. So this one, like for example, this SA is referring from C to position go down on the left. And datum SB here is from B and go down this line. So don't confuse between these two. Okay, A is A, B is B in this case. So in this section, when you look at dependent motion, you look at individual object and then you compare what happened if you pull, then it will affect. Okay, this one you read. Okay. Okay. The positive sense of the direction. Now, how do you link these two objects together? There's only one connection point there. What connects them together? This, right? The blue, the black color line. This is the only thing that link the two objects. We are using this link to derive equation for V, A, and T between the two objects. That is the most important thing when you see this pulley system. Then you identify the reference point and then this line. This line. Okay. Now and then yeah, okay. First, okay, this kind of question. First you look at the where's the origin. Second, you look at the datum. Sometimes you need to build your datum. Sometimes you need to build your datum. So it depends on the question. But okay. The second one, you link the two objects with the total length. LT equal what? You look at the diagram. For example, this one. How you calculate the total length? You take what? What plus what plus what? You have three sections there, right? So you take what? SA plus CD plus SB. That is the total length. However, okay, this is the common things lah. So LT is the total length. So CD is the section that pass through the two datum here, right? And if you, no matter where you pull, either you pull to the left or pull to the right, does this length change or not? Does this length change or not? No, right? So if this not changing, it's actually not helping your calculation for your velocity. Okay, so this is the next step. First, you get the total length. And normally, in the analysis, we will take out the red color region or the fixed region. We will not calculate the fixed length that always, no matter where you pull it, the length still there. Means the fixed length, the red color, we will take out from the equation. All right. Now, why we take out? We take this equation. The next step is number 4. You dl dt. dLt means you time differentiate what you get. Like the section previously, you know displacement, right? After then you learn about velocity. The velocity is dx, this t. Right? So now this is your s. LT is your s. So you want to get the changes of the length. You derive equation. So when you dl dt, what you get? You get dsa plus dsb. Of course, you can plus d LCD or dt, dt, right? So what happened to changes of LCD? It doesn't change, right? So this one becomes 0. So in the equation here, that's why I don't put in the LCD there. This one a bit fast lah, a bit fast. So there's one more here actually. So I just now when we take it, the things, so the change of the total length doesn't change because we assume that the rope is not flexible. It's rigid. So how many you pull from one side, it will transfer to another side. Right? So this dl dt will be 0. Unless the question gives you a flexible, then there's an equation here. But for the starting, we assume all the rope is rigid and it transfer 100% of the energy. So 0 on the left hand side, and you only have a dsa dt plus dsb dt. Of course, there is a dlcd dt, but this one doesn't change over the time. It's always locked there, right? So 0. So that's why you get this equation on the slide here. Make sense, huh? Okay. What is SA over dt? What is this one and this one? What is the definition of velocity? ds dt, right? Yeah. So this one become velocity of A, velocity of B. Make sense? I mean, we look in terms of equation. Okay. So you get VA VB. VA plus VB equals 0. This one tell you the relationship between two objects. So always the same. When you solve this kind of question, you start from origin, start from datum, then followed by calculate, identify where is the total length. Then you move to time differential of your total length. Then you go to this one. Then you get one equation, relationship between A and B by velocity and acceleration. Now, we stop for a while here. We go back to the diagram. When you pull A down, when you pull A down, what happened to B? B go up, right? Where is the B positive direction? Go down. Make sense? B, it already tell you already. Datum must be measured from here. Positive direction is go here. But when logical thinking, when you pull this one, B will move up. So it will move in a negative direction of your datum. It means you pull this one, B will also move, but it moves in the negative direction of A. Makes sense? So this one, if you not negative direction, but if you move this direction, this equation, VA plus VB equals 0, you pull VB to the right hand side, what you get? VA equal to negative VB. It tell you that actually the velocity between A and B, they are opposite direction. From where? From the datum. Although like this diagram, you pull A, of course B is following A. You A go down, B go up, right? But mathematic wise or from the datum, they are different. Sense, okay, so here you combine these two, you get the first equation, the relationship between two objects, VA equal minus VB equal to minus VA, or VA equal to minus VB, same meaning. It just tell you, and again, this is vector. When you have negative sign, it means both of them they are moving in the opposite direction. Referring to datum. Referring to datum. Referring to datum. Okay, you get a negative sign here because your datum is positive. For B, go down. And it look logic. If you pull A, B will move up, which is correct with this equation. Okay, so everything when you check up to this stage, it must be logic. If you this one you get positive, wrong already. VA equal to positive VA, then you look back at the diagram, refer to diagram, refer to datum. If this one both positive, it means you pull A, B will move down because your datum positive go down. So up to this stage, always do double check. Correct or not? My VA and VB correct or not? In the common sense, does it correct or not? Referring to datum, the movement, does it correct or not? If wrong, then you need to check your positive and negative sign in the calculation, because once you make correct mistake from here, the rest will wrong already. The rest, your answer will wrong already. So this is half question. So this is a checkpoint. If you don't check here, the rest will wrong already. Why? Because what is the definition of acceleration? A equal to dv dt. You're actually using what you derive here. Continue with the acceleration. Okay, so the rest is just an explanation. So you do the same for acceleration. Basically, velocity and acceleration is linked together. So if it's opposite direction, then acceleration also opposite direction. So you change VA. So next steps once you get the V, the next step is to get straight away copy the equation, change V to A. You write VA equal VB. Then the next one you write A equal to AA equal to AB, something like that. These are steps. Basically, you doesn't go wrong one. This one is I can say it's a no-brain question. Basically, it's you follow the steps, then basically you're able to find the answer. It's only what confuses you is the diagram, and you are confused in your datum. You don't know where is the datum. Then you confuse with the positive, negative already. Okay, it's very easy. For example, this one. I give you an example. When you change the datum, the answer will be different. Not answer will be different. The positive, negative sign in your answer will be different. The end answer will be the same. Okay. Now, if you look at this one, first you look at where is your datum. We have two objects, right? First, you think logically first. If you pull A, what happened to B? Pull A, B will move out, right? Okay. Then, if you move SA positive to the right, what happened to SB if you pull A? Positive or negative? Negative, because B move up. This one positive go down. So E is a positive SB. Before you solve it, you start to think all these questions first, right? Then you know that S is going, there's a positive direction of A and B already. So the first guess is your VB, VA will be negative VB, A will be VA, A will be negative AB. Without going all the step first, I mean, you look at the question like where is positive and negative. Okay. Now we start doing the analysis already. The step is the same. First, you look at the position. Where is your position? This position is referring to datum. Your S is always referring to datum, and you are given the direction. Where is positive? Where is direction? Where is the positive direction? Okay. Now position of A and so on. So this one we already explained how to get datum. Where is positive? Right? Once that you go to length. The next second step already, third step, you go to total length. How you calculate total length of the rope? You take SA plus H plus SB, right? You write lah, LT equal SA plus H plus SB. Next step, you do time differentiation for the total length. What doesn't change? H doesn't change, right? H is fixed, right? So you can cancel the H. Then you arrive at this one, total length change or not? No, 0. This side 0 equal SA plus SB dt. This one 0. Okay. You already explained this one. So this one again, this one careless mistakes. If you only put one SB, then your calculation wrong already. Why? Total length is SA plus H plus this section plus this section. Careless mistakes always. I will give you more than 2 pulley usually. Give you hints already. You more than 2 pulley. You always have one section that have double length here. Okay. So here, again, I'll show you the careless mistake already. 2SB to calculate the total length. Total length, SA plus H plus 2SB, SB plus SB. Careless mistakes always this section. You will miss out one SB, then I don't need to mark already. Basically wrong already. Okay. All right. Now the rest is at the end you arrive at 2 VB equal to minus VA. Or VA equal to minus 2 VB. What does it mean? What does it mean? What is the ratio between VA and VB? Which one moves faster? VA move faster or VB move faster? Why VA? You think why VA? You have this equation already. You agree, right? This equation, right? I'm asking about the speed. Which one move faster? If you move VA with 10 meter per second, what is the speed of VB? By referring to this equation. VB move faster. Why? You have two length here. You pull this one will move very fast. By this equation. if VA is 10 meter per second, your VB will be, your VA is faster, correct? So VA is 10, your VB is 5. Your VB is 5. Correct, your VA, just now the answer, VA is faster is correct. Okay, so something like that. So you make judgment based on your calculation, based on the numbers. Okay. So same with the acceleration, you just change the V to A. It'll be the same. Because these are the steps to solve this section. Right, so I'll go a bit fast. Right. So when B move downwards, A move to the left. Twice the motion. So this one is the section C kind of question. We ask you what happened to A and B after a certain time. Okay, from this, you explain what is this. Okay, and the question I'll ask you, like for example, what happened to A when B moved down? So when move down, positive SB, A will move to the left with its negative SA. Negative, negative SA, with twice the motion. Okay. Make sense, This one, this one, this one, Oh, H is fixed, right? So the position moved by the A and B, you can see from here. If you move A, if you move B, A will move double of B, because this is a ratio. It's a ratio. Okay. All right. Now this is the diagram you see. What happened if I change the datum? Oh, you wrongly put the datum. Do you see the changes of datum? What changes? What changes? SB datum change. Left hand side datum is from the top. Right hand side datum is from below. Same motion. You pull A, B will move up. But now your datum change. You see what happened to your calculation? See what happened to your calculation? Your total length now change already. I mean the calculation, the way you calculate. How you calculate your total length? SA plus H. This is the section you want to calculate, right? So you take H minus SB multiply 2. How you calculate this length? This length is, you take H minus this one, right? You get only one section, right? But this one got two sections. You are calculating this one plus this one and this one and this one, right? So is 2 bracket H minus SB is this one plus H plus 2SB. Careless mistakes always, when you're seeing this one, you panic already, and different datum here, you confuse. So be careful, this one, the LT. LT can be very tricky. Always referring to datum. Then look at the length, you focus on the length, the rope of the rank, and not try to like look somewhere else. Once you have this one, you continue with the procedure. You regroup the things, right? You regroup the things, so this one will put inside 3H, but you know when you differentiate H doesn't change. This one doesn't change, so you still get 0. Right? At the end, you get 2VB equal to VA. 2 positive. Why? Because they are referring to datum. If you pull, if you move A, B will move up, right? So you agree with the datum. 2 positive. So be careful on the datum. Datum can be tricky. you can change your calculation from negative to positive. But the movement, the motion of the object still same. It's only your calculation become negative to positive. Make sense, huh? So these are the correct mistakes. You change B to A. Okay, so this one just a highlight, like go and think like why here the sign say Y. Actually, the main point is you already change the datum. You already tell the computer where is the positive direction of your movement from the datum. Okay, so just be careful on that. Okay. Let's look at this analysis. So determine the speed of block A if block B has an upward speed of 6 meters per second. Okay. Again, all the tutorial question already in the canvas. So if you want to, you can print out all the tutorial question without the answer from the canvas before the class. So you don't need to copy the question every time. Okay, so he asks you to focus on A. Right, now before you analysis, you look at the diagram. Try to think logically how the two objects move. Okay. All right, so I hope you understand the diagram. So this one is a roller, means it's only fixed to one direction. Okay, so if you move B upwards, what happened to A? If you move B upwards, what happened to A? A will go up or go down? Go down, okay. Once you know that it's go down, then you look at the datum. You look at it asks you to determine speed, right? Look at the datum of A. You know that move up, B move up, A will move down. You look at the A datum positive go down. So your answer for velocity of A and acceleration for A will be positive. Before you move to the next steps, like you think, okay, what is the answer? Whether it's positive or negative at the end. The answer is positive for A. Because the datum positive go down, and if you move B up, A will move down. So you agree with the datum. When it agree means it's positive. Before that, then at the end you do negative, then something wrong in your calculation. You mess up with the positive negative in the things. Okay. Okay, let's look at the procedure. Same. So you'll see normally in the question you won't see red color in the question, but this just tutorial. I just highlight to you that there are some portion that doesn't change. So don't you include that in the calculation, but when you you differentiate over time, basically you cancel out. You take out the things. All right. And remember, you only have one chord. Sometimes you have two chord. Some question you have two line. So when you have two line, you have LT1, LT2. Don't mix the line together. Okay. In this case, you only have one. How many line you have? You have okay, one line in this case, right? Now, okay, then the positive negative sign I already explained. All right. So basically, the next step is where is positive, where is negative, and so on. Okay. Then the rect segment you don't need to include actually. You don't need to include. But you can include if you want. But normally, if you do more exercise, you know that you can skip the red color section. Straight away calculate the total length. Okay. Now in this case, total length, we straight away to calculate. You know how to calculate total length of the rope, right? Or the we call the important length of the rope. The red color we ignore because it doesn't important. And when you time differentiate, they also get 0. So how get the total length? That's A plus this one plus this one plus this one. So you have 3 SB. 1, 2, 3. This one doesn't count because doesn't change. This one doesn't change this length. Okay. Okay, this one was hook, so doesn't matter. Okay, so LT equal to 1 SA plus 3 SB. That is the first step in calculation. Once you find the L, next step is to find velocity. You know position to velocity. Velocity equal to ds dt. So take this one, differentiate with time. You know that total length doesn't change. 0. Okay. So 0 equal to S become V. S become V. Rearrange the equation. It depends on what your subject is. In this case, is A. The question asks you about A. So move your A to the left. Okay, the question asks you about block A. So this one, you move to the left. You can move this one to the left also. VA equal to minus 3 VB. Makes sense? Because when you pull A down, B move up. So, but the datum is positive go down for B. So it makes sense. We agree with the equation here, agree with the diagram there. It must make sense. So if something that doesn't agree, then something positive, negative sign is wrong. Or you misunderstand the datum. Datum already give you the arrow. Where is the positive direction? Okay, the next step is, you know lah. So if we have VB is minus 6 because it's moved up there, upwards, right? So VA will move down 18 meter per second. Why? VB move up negative, right? It move up VB negative. So this one move to the left, you get negative. Negative, negative, you get positive. Negative, negative, because this one you move to the left, you get negative 3 VB. Your VB is negative. Careless mistakes sometimes is here. You straight away, you read from the question, you put positive, means you do not check your datum. Datum is very important in this question, this kind of question. You will see this one, VB move up, your datum is go down. So remember to change this one to according to datum. You're always referring to datum. If not, then this one, VA, you will get negative answer. Negative means something wrong with your numbers here and the real scenario. Don't confuse the positive negative. Be careful on that. Okay, so any question? No, right? We do the same. One more question, same. You'll see that the procedure actually always the same. Next question. Find the speed of A if B is upward speed. Before you do question, you look at the question. How many pulley you have? How many line you have? In this case, you have two complete line. You have two line. The previous example 14, 15, you only have one line. But this one, you have two line. So when you have two line, you need to have two LT, LT1, LT2. Okay. Now when B goes up, what happened to A? Move up, A down. Okay. Do you see the different line here? This is one line. This is another line. Okay. Okay. So again, this question have two chords. So you need to think outside the box a little bit because you need to relate what is your SB and FA. How you do it? Okay. So this one is already explained why the highlighted red section you do not consider because it doesn't change. So it doesn't have your VA and your velocity and acceleration analysis. Okay. So the first length we take SA plus here plus here. So SA plus 2SC. Get this one. Okay. Okay, get this one. Second one. Here plus here. Right? Here plus here. How do you get CD? Okay. So you convert this one with SB minus SC. This one minus this one. Then you'll have two SB already. Okay. So you do the time derivative for this one and this one. You do this one and this one. Does it change L1? No, 0. Does it change for L2? No, 0. Okay, you'll get the first one. This one become this one. This one become this one. You time differentiate dl dt, ds dt, dsa dt, dsc dt. You get this one. Then you do another one. This one, dl2 dt 0, doesn't change. SB, we have 2, so become 2VB. Negative copy. This one, ds dt become BC. We have two equations. What do you think the most important parameter? C. Once you find BC, you can find these two. Right? This BC actually linking what is A, what is B. So want to eliminate C, what do you do? Substitution. It's like solving equation, simultaneous equation. So what you do, you substitute, because here, you move VC over here. VC equal to 2VB, you substitute inside here. You get relationship between A and B. So what does it mean? A and B, there's a ratio of 4. Means you move BB, VA will move 4 times faster than VB. You put 1, this one becomes 4. To balance. There's a way you try to interpret the data. So it tell you VB move upwards 6. Again, this is a careless mistake. Some of you just copy positive value. One SB positive go down. So this, so remember. So when you substitute negative, you get back negative. So you pull this one minus 4VB, negative, negative, you get positive. So VA positive. When you get VA positive, again, check the datum. SA positive go down. Make sense? So when you pull VB, not pull B, push VB, B up, A will move down. So you get positive sign. Because datum down positive. Tricky part here is to link between two ropes by substitution. Okay. Okay. Now this kind of question in the final exam question. This is come out once, but I modify a little bit in final exam. Compulsory answer kind of question. Means it's either question 1 or question 2, compulsory to answer. So a man at A, so this is a concrete man, try to pull this object out by using pulley. So you're given a parameter of that position, and you're given datum, although there is no datum. So in exam, we don't tell you the datum anymore, but we'll give you arrow. Positive this direction. We'll give you an arrow. For example, here, this also datum. Give you arrow, positive go up. Okay. So a man at A hoisting a safe show in a walking to the right with a constant velocity VA equals something. Determine the velocity and acceleration of the safe when it reached at a certain height. So we pull this man, walk, then this one go up. When this one reach 10 meters from the floor, it asks you determine the velocity and acceleration. The rope is 30 meters long and pass over a small pulley end. Give you a total length. So in this case, you need to derive one equation. Derivation of equation. What is the equation expect from you? This man walk, right? Man walk. So there is an equation of x direction. And this one walk, when this one walk, this one will change, right? Y will change. So there is a relationship between y and x with the v. Right. Okay, how will you move it? Okay. So this one is previous example. Okay, this one you read lah. Just highlight. They must be measured from a fixed point and meet the scenario that you see in the case. Okay. So the first statement, it gives you the total length. It's like you reverse back. Previously, we add all the segment. This one, it gives you a total length. So you need to think like, how I get my total length of my rope from the trigonometry diagram. Right? Total length, you take this length plus this length. Right? Correct. LCD plus LDA is what you get the total length. You know trigonometry equation, right? You know the x, right? You know the y, right? This one. And then you find the Pythagoras. You have the Pythagoras or you have this one. So you want to find this one and this one. X you don't know. It's a linear equation. It's a linear equation. So using Pythagoras, your L, this one, square equal to this square plus this square. Like 15 is a total length, total height, plus X you don't know. You just don't, when you don't know, you just put a parameter. In dynamic, when you don't know, you just put a value there. At the end, you will find it. Don't worry. In this case, you don't know. You just put some value. Some constant value. Not constant value. Alphabet there. So here, you know the dA. Okay. Now you can calculate CD, right? LCD. This one. LCD also changed by time. How you calculate CD is 15 minus Y, right? This one minus Y, you get the length of CD. So basically, you have three equations. You just substitute this one inside here, this one inside here. You get a total length equation. It's like a Lego lah. Important is that you try to relate. You see it as a Pythagoras question. Then you slowly put in what you know. Then you substitute. You get the total equation. This is the equation that we're expecting you to derive. Rearrange it lah. Nicely. Equal to what x? Okay. Y equal to something x with the square root of something. Is what we expect from your Pythagoras understanding. From this diagram, you derive equation between y and x. Okay. Once you have the equation, you have the equation of y. You can find the changes of x, the velocity of x, because you already have the y equation already. So what you do, you divide the x equal to velocity of the safe, this direction. VA, you know, this direction you know is dx dt, right? Change of x in time. So VA equal to dx dt. So this is it's not chain rules, but it's a products. I think the name for this procedure is a products, vector products or differentiation products. Means you dy dt, you break into two mathematics form. You write dy and dt here, and this one is free to put one. It can be other parameter. because you can cancel it out. Basically, it's just the same thing. You arrive at the same thing at the left. So you break into two components. One is dy over something, something over dt. Then you look at what you have. You have dx here. So you replace the empty space here, dx. Okay. If the question change this one to p, q, this one is p or q, then replace p or q here. Okay. You know how to continue from here, right? This one equal to dy dx. You have your y equation, dy dx. You have the dx dt, this one. Put inside here. Right? Things that you don't know, you remain. Like for example, dx dt, or you don't know how to do, copy. Then do the dy dx first. How to from here to here, I go check. This is mathematics. Okay. Now you do all these things. You substitute this one inside here. This one Vs equal to something Va. Okay. So it give you the position already. It asks you position. When reach certain y, 10. So when y at 10, what is your x? Here, y is 10. Where is your x? Square root it. Press calculator, you get two roots. Got square root. Got two roots, one positive, one negative. You need to decide which number. This one, x to the right. You pick the positive value from the calculator. So x is 20 meter. So when you have no x 20 meter, substitute here. You know this one? Pick here. Here. You know VA, right? 0.5. Substitute here, you know your VS. Okay. Then for acceleration is A equal to dv dt. Differentiate this one. Acceleration of self, differentiate. Okay. dv dt or A equal to ds square over dt square. If you're not confident doing this one, you go back to here, double differentiate this one. There are two definitions of A earlier. One is velocity, one is position. Okay, so your homework So you can choose either you want to continue from here, or you can pick this one, double differentiate this one. Both arrive at the same answer. Right? A will get something, VA. Substitute You just substitute You know your X, right? You know your VA, you know your when the Y equal to 10 meter, you know your X, right? Yeah, this is the things. Okay, so the rest I also give you the working, so no reason you don't know how to do, but this one your homework you go and see. There's a steps of derivation of differentiation. Go and okay, it's a long steps. Okay. But again, you won't see this one in your test, you will see this one in your final exam. Okay. Of course, if you seen this complex calculation here, normally I will attach an appendix for differentiation for you. I will help you a little bit on the appendix. If this kind of complex things come up, I will still help you with the appendix. Right. So this is where you get it. You just substitute and you get the answer. Okay. Okay, this one I go very fast. Basically, it's only one equation that is important. So what is the important part for this one? It's a relative motion of two particles using translation axis. What does it mean? You have a fixed observer, you have a object moving, you have an object moving. Means you have 3 reference point now. Previously, you only have 2. Now you have 3 reference point. One fixed, one object moving, one object moving, but it is an observer. Translating means this one moving, but it's try to start to observe object B. And then there's a fixed reference point from there. It's like a tracking algorithm. It's a tracking algorithm, right? How our GPS can lock on to your phone or that one is using this approach. Huh? Yeah. This one all you read. All the R, you know lah, from this diagram, R is from here, R is from here, and then this is the RB stroke A. I want to highlight this one. Huh? So RB stroke A, RB stroke A, it just means B relative to A. Relative for A. In your calculation, I give you a shortcut. You convert the slash into RB minus RA. Convert this one to negative. This is a vector equation. It's a vector equation. But summarize everything. You just remember when the question asks you what relative to what, change the slash into negative. Write this equation, then substitute value inside. From position to velocity, from velocity to acceleration, same. Okay, this is like position. So we change position, then to velocity, you just time differentiate, then time differentiate, you get acceleration. Okay. Okay, so this one I already explained just now lah. There's a cheat code there lah. It's the same, like what I read on there. So you can write this one to A, this one to here, RB minus RA, then equal to RB stroke A. But the way I memorize is I straight away use this one, change this one to negative, and just copy RB minus RA. So I don't need to like try to figure out like how you do, right? And so on, huh? Actually derive from there. This is depending on the question, like this is the final question that the question expected. Like for example, the question asks you to find B, find B, find B. What happened to object B, the position, velocity, and A. Okay, this one I go very fast on how to achieve that. So this one have one object and the train. Huh? The train move in this direction, A move in this direction. Okay, it give you X and Y, but there's a resultant velocity here. Huh? Okay, so it give you all the parameter. So you find magnitude, direction of velocity of the train relative to the automotive. So basically, you see the question, something relative straight away is fall under this category. This equation will become out. You just replace the A and B is what object only lah. Okay, and you say train relative to A means B relative to A. You change the A and B accordingly. Okay, so vector analysis I already explained, right? Train relative to A, so VT minus VA. But of course, you can rewrite in this beautiful form. You want to find VT, right? After you write the one that I write on the whiteboard there, you rearrange. VT, you write VT equal to VA plus VT stroke A. Or you can write VT stroke A equal to VT minus VA also can. It doesn't matter. But because the question asks you the train, asks you the train. So why? This one is vector. You change everything into I, J, K. This one, you only look at two-dimensional problem. So VT is X direction, so 60I. Okay, 60I. What is VA? VA, you change this one, 45, change to X and Y. So you use cos 45, you cos sine 45. Right? This one, you change this vector into here and here. This one, here to here. So you have two vectors. So you have the car itself, you have 28I minus 31.8. Okay. Then from here, we have two vectors. One is I, one is j. You find the magnitude or resultant. You have I and j, so square this one, square root. Like what I draw on the below there. Positive to the left, negative go down. Negative go down. Okay, the magnitude you square root, you get this one. What is the direction? Is a trigonometry. Tangent something here. Tangent this one and this one. So you get the angle. Okay. 19 also same. This one go home, go and read. Then go and read this example. Yeah. It's the same lah. It's the same. Actually the same. They ask you what refer to what. So same. Applying the object. Example, you read the question. Determine the velocity B as measured by pilot A. B as measured by pilot A. B as measured by pilot A. B stroke A. So write VB minus VA equal to this one. Substitute accordingly. Draw the vector and so on. Okay. Okay, the rest you read. All the information is there. Remember, tangent, normal, tangent, normal acceleration V square over rho. This one is a combination between the normal and tangent because you got curve and object. Don't confuse this one with the radius polar coordinate. This one object, so you have tangent and normal. So you have the normal this one. Okay, the rest is the same. Blah blah. And you draw the things. Okay, so with this we conclude chapter 1. So chapter 1. Yeah. Sign your attendance if you haven't signed.